with ISSoft and Coherent, and this will be the English part of the presentation. I don't know much. Can't hear me? Uh-oh. Can you hear me now? Good? Better? There we go. Better. Okay, we'll start again. I'm Paul Fredriksen. I work for Videology. Have some colleagues here that we work with from ISSoft and Coherent, and we'll be talking about ELK today. Does anybody here know about ELK? Use ELK in production? Probably about a third of you. Anybody? How many people have heard of it but have never really used it? Okay, cool. So this might be actually pretty useful. I'm not going to get super technical on what the internals of ELK are and what you can do with it and go into lots of searching. This is basically a very simple overview of this is what you can do with ELK, and this is why it can be useful, and this is why pretty much everybody in DevOps should be using something like ELK. There's other products that do the same kind of thing. There's Splunk, Sumo Logic, other products that do the similar things. But this is the open source, quote unquote free, as long as you're paying for hardware to do it. So ELK is an acronym. It's ELK. There's Elasticsearch, Logstash, and Kabana. Those are the three basic pieces of it. They're all owned by the same company that they released this on open source. It's called Elastic Company, and they own all these products. They're all open source. If you have problems with it, they are on IRC. You can always get to them. Their developers sit on IRC, and you have really good access to them. So I'm going to kind of go in order, what Elasticsearch is, what Logstash is, and what Kabana is. And, just to kind of give you guys some insight on this actual presentation, this is a presentation that we actually gave internally at Videology to kind of inform people of what Elasticsearch is and why it's coming. And so this is exactly how we would have presented it to our company as well. What is Elasticsearch? It's a distributed RESTful search engine, replicated, highly available. Read and search always happens on replica shares, so on everything that's being written, you're not actually doing reads on, so it makes that faster. It causes it so that you're not having any contention. Multi-tenant, multi-type, multiple indexes, multiple types in indexes. It's all document-based. It's all JSON. It's all very easy to read. Everybody here probably knows what JSON is and can write it and read it at least. It's a fully featured API, and it's built on top of Lucene. So if you know anything about Lucene in the Apache project, it's very similar. The setup's very similar. It's basically just a big fork of that. Elasticsearch, I'll also kind of go into. Elasticsearch is basically the database engine of ELK, and so all of your information goes into there. So when you're ingesting log files and sending logs, and I'll go into more what you might send into Elasticsearch, but it's usually things like that. You end up with potentially terabytes worth of information in there, and it becomes very fast and easy to do. The next piece we have, and this is the hardest piece, Elasticsearch, pretty simple to set up. The AWS actually has its own Elasticsearch service. That way you don't have to worry about the sharding. You don't have to set up the sharding yourself. You can do AWS takes care of all that for you. AWS, like a lot of the things they do, they make it easy enough where you can just say, hey, I want an Elasticsearch cluster. It needs to be this big. This is how many nodes underneath it I want, and go. And they make it very easy. They make it very easy to add storage. You want to add storage, you just tell it you want more storage. It incurs no downtime on that. The complicated part of Elasticsearch or of ELK is Logstash. This is the piece where you're actually telling, basically telling on an operating system, on an instance, what information you want to send into Elasticsearch. This is basically turning all of your log files into a JSON document and dumping it into Elasticsearch. What is Logstash? It's a tool, like I said, that allows you to manage logs via inputs and outputs. The great thing about Logstash is you don't have to use it directly with Elasticsearch. You can actually use this to input and input and output into S3. You can input and output with email. You can do it with just files. You can do anything with it. So let's say you have a log file and you want to email every single log that comes in. You can do that if you wanted to. But kind of the idea of using ELK and Elasticsearch and Logstash and all of this is to make it so that you don't email, but it's a possibility. One of the things we're doing is we're actually taking some log files and we split it where we have two outputs. So we send some of the logs to S3 and send some of them to Elasticsearch, and you can filter on all that, and I'll get into that. Like I mentioned, you have inputs. Some of the examples of inputs that you can use are TCP ports. So you can open up a TCP port, say port 8000, and anything that comes into port 8000, as long as your filter matches what you're looking for, you can actually send that into Elasticsearch safely. We use that a lot for some of our network appliances because they allow for that. You can use files, and as I mentioned before, you can use S3. You also have your outputs. Outputs are pretty much the exact same thing as your inputs, except they allow you to send to places instead of allowing you to get to places. So output examples, Elasticsearch, files, and S3. This is all extendable. It's all open source. Not an output or an input that you know about, you can build one. So if you have your own application, your own Java application, and you want to be able to send metrics or information that your application generates, very easy to create your own custom output for that to send to Logstash. By the way, if anybody has questions at the end, I'll leave it open for questions. Here's a quick and dirty example of what a very simple configuration for Logstash looks like. As you can see, we have a file input. This isn't. Can you hear me better now? You have a file input, and you can see there. These are just your basic Linux operating system logs. You have your messages logs, your demessage logs, and basically anything that has .log, take it and send it to there. The starting position basically means you can tell somebody, you can tell Logstash to start from the beginning, or you can tell Logstash to start from, when Logstash has started. So what this would do essentially is take logs from the beginning and send into Logstash. And now you have, this is also all inputs. This is an S3 input. It's an example of one that we have. So we're taking some of our ELB logs and throwing them into Elasticsearch. So it's very easy to set up. It's your bucket. That type we'll go into in a little bit. The type is basically how you're filtering things. You're telling it this is what log files look like, and you're splitting them up into groups. Your region prefix is basically the directory structure, and your access IDs and secret keys, which I was smart enough to actually remove. And here's an example of an output. One problem with the Amazon AWS Elasticsearch service is everything that you send, you have to sign. You have to sign with your key every single log file that you send. So Logstash by default does not have an output for the AWS Elasticsearch service. You can do it a couple ways. You can set up a proxy service that would actually sign those on behalf of you as it sends it through. Or there's actually a third party, somebody built a custom plugin to do this. And so that's pretty much the example of it right there. It's very simple. You set up your host file, region, same kind of thing. You're seeing kind of you're seeing kind of the AWS way for it. They always use the AWS terminology. Indexes, that becomes very important later on. Your indexes, that's how everything's sorted in Elasticsearch. So you can have multiple indexes. You can have hundreds and thousands of them if you want. This allows you to actually remove data and search data much easier through some of these, kind of be able to manage Elasticsearch a lot easier. If you're sending all of your logs into Elasticsearch, these numbers can get very big, and you may not want to keep things for years. You may only want to keep things for a month. So we actually go in every day and purge, usually the last month or so of data out of Elasticsearch. We don't keep this as data that we would keep forever. We keep that for S3 because you can always ingest something from S3 later and take pieces of it. So this keeps kind of our data manageable, our cost manageable, when it comes down to that. And it basically uses your generic date formats, your Linux date formats to do that. Here's an example of a TCP input. You can see here we're taking a port 9000 syslog, and it's Palo Alto logs. So we're taking some of our VPN logs and putting them in there. It's very simple to set up. You can see that this is really the hardest config piece of Elasticsearch and ELK, and there's really not much to it. It's just a lot of data to deal with. So when you want to deal with when you're sending logs into ELK and Elasticsearch, the problem is you have this big chunk of data. So if you have a messages log and you have one line, you have this big, long, giant line that you really can't parse very easily. It ends up in Elasticsearch. It's not indexed well. You can't say, let me see if I don't have an example up there, but there's very obvious things in logs. There's patterns. You can say there's always a date, there's always the host name, and if it's something that you can guess that's going to happen, it's easy to make these filters. So grok filters. This is the way that Elastic Company explains what grok is. It says grok is currently the best way in Logstash to parse crappy, unstructured log data into something structured and queryable. That's their official line on what that is. So it's pretty interesting. So if you want to actually set up some of these filters, you can set them up in a pattern. I think I have it. Hold on. I feel like I'm missing a slide. Anyways, so we have a pattern. You have your message. So you can see here in the messages folder here, you can see this is I think this is an Apache request. So you can see what we have there is we have the message, and it takes the whole message. It says this is the whole piece of it, and now we're picking bits and pieces out of that. So you're actually, if you see there, it says pattern, identifier, and type. So your pattern is actually, a name that you're coming up with, and the identifier and the type. And the type is is an optional field. So you can say if it's an integer or a float. So you can see here we're calling it a IP client. So we know it's an IP. Logstash knows what an IP address looks like. So we're actually calling that, we're renaming that and restructuring that into client. Now we say word, we're actually calling that method because it's probably a get or a put or something like that. You can see URI path param, and we basically change the name of that and we call that request. Same with bytes and duration. And the reason you do that is because when you go into Kabana and you want to start searching through some of this information, it becomes very hard to search through this whole list of the log. So if you go in there and you want to actually, have it more human readable and you can understand it, now you can say, I want to see every client that is sending this type of method that took longer than this duration. It allows you to split those all out, and those are all indexed separately. So it makes it much easier to go through that. So you'll see below that what that translates into. These are just examples of the client IP address, the get method, request, bytes, and duration. Kabana. So I'll move on. This is really the hardest part of Logstash is getting not necessarily the inputs and the outputs together. It's getting the grok filters together. And if you go on Google and search for how-to grok filters, it's pretty much all out there. There's lots of good grok filter parsing websites where you can actually take that piece of data that you're trying to parse together, and you can put it in there, and it'll actually show you what that output would have looked like in JSON. so you can get a good idea of what it's actually trying to send to Elasticsearch. So Kabana is the fun part of ELK. Kabana is the part where you're visualizing things. It's the part where you're taking to managers and saying, hey, look, we have lots of pretty pictures, we have graphs, there's big spikes and low spikes, and this is the part where you can actually show people things. What is Kabana? It's the graphical front end to Elasticsearch. Do you need Kabana to work with Elasticsearch and Logstash? No. All three of these pieces can be used independently of each other. Kabana basically allows a good front-end interface to Elasticsearch to allow you to query it easy, to visualize what you have in there. Allows you to build graphs, share graphs, and search. So we have a few examples of things that we have in Elasticsearch. You can see here, these are some of the easy wins that we were able to show very quickly when we started using Elasticsearch. We were having a problem with API calls, and I think Artem may have talked about it earlier when he was talking about data flow and transfer. But you can see what we did here is we were taking some of the network logs and looking at the network logs, sending them, to Logstash through the network input, and then sending it to Elasticsearch. And it allows you to see here who's sending the most API calls, because we were having a problem with API calls where we were using too many of them, and so when we tried to build instances, it would come up and say you've exceeded your API limit, and there's AWS gives you no ability to increase that limit, unfortunately. So you can see one interesting thing here is you can see, hey, wow, there's a lot of API calls coming from that IP address. And it became really interesting, but then we found out, hey, that's actually our NAT address, so it kind of makes sense that everything's coming out of that, that thing. So we actually had to dig a little deeper into it. But you can see this is a very simple, it would take you 5 minutes to put together, seeing where things are coming from and where they are. Top tens, lists, bar graphs, pie charts. And this is a very simple systems graph. This is actually quite old now. I think we have closer to 300 hosts going into reporting into Elasticsearch directly now. And this is just a basic dashboard of just showing you the kinds of things you can do with it. So I'm really just showing here how many log files we're sending every hour per instance, who's the top, the top 100, just histograms of, when the hosts are checking in, and a histogram of the host counts and the number of documents being sent per hour. And like I mentioned before, this has grown significantly since I've put this together. I think we're closer to 3 million documents an hour. Just another example of things we're doing with Kabana is this is one of our products that we use, and we're able to visualize based on where requests are coming from into that application with the ELB logs. So you can see there's little dots everywhere where these are happening. And there's a little graph, I guess it's kind of hard to see right there, but there's a graph that says how many requests are coming are coming to each of these different places. So the light yellow is 1 to 27,000 requests. So you can see the red is, we're out of Baltimore and DC, so that's probably why a lot of it's coming out of there, a lot of the large data centers. And here's another example that I've pulled off of Google, basically showing just more information that you can pull out of Elasticsearch. You can see what they did there is they're showing locations, they're showing web transactions, database transactions. This would be a great way to correlate information with something like Grafana or Datadog or something like that. Is you have this big graph where you can look at it at a certain period of time. You can say between this time and this time, what's this look like? And if you are having problems, you can correlate that with this probably. It's a great correlation tool. That was one of our biggest problems, and one of the reasons we started using ELK was because we had great information. We had decent alerting. We were using Grafana, Nagios, all these things. But the problem is we didn't have one big way where we could correlate all this information together. And Elasticsearch is helping us do that, taking some of that information we have and digging deeper into all these logs. We had, just billions and billions of logs that we couldn't actually do anything with because they were sitting on servers. So if there was an issue, you were going out onto an instance, researching these log files manually instead of actually having a way where you can put it together, visualize it, or a way where you can search through things and find things. This is a really fancy one that I found off of Google Images. You can see where you can do heat maps, pie charts based on country codes, where information's coming from, and refers versus destinations. So you can get really intense and really complicated on how these things work, and it's all near real time. So it's really helpful to deal with. It's a great way to show your managers what's going on in your infrastructure. That was a lot. So questions.
Any questions, guys? Oh, Artyom. Okay.
What clients you use for sending logs?
What clients do we use?
What clients, yeah. Do you use Elastic Beats or something else?
To send the logs, so we're using actually Logstash on the servers themselves.
So each machine
yes.
Run Logstash?
Yes, yes.
You have a lot of RAM?
We found it doesn't take, so we're coming into an issue where we are starting to look at some of those different clients out there that will actually send them through TCP and dump them into these different places. But typically in our environment,